Hello and welcome to part 13 of the C programming series on the channel Technical Utkranti. By the end of this video, you will be able to appreciate the use of pointers and quickly identify the reason of segmentation failures. So let's get started. In the previous video, we saw some concepts related to memory, what is physical memory and what is virtual memory, stack and heap, and a brief introduction to pointers. I suggest you to go and visit the previous video, which is part 12 of the C programming series. In this video, we will see important concepts related to pointer and what is segmentation failure and what are the main reasons that lead to segmentation failure. Firstly, we'll see casting in pointers. Let's look at a basic program involving a pointer. Fine. As you can see, this is an integer I with value 10. I've created a pointer and assigned the address to the pointer of this variable. When I dereference the pointer, I'll get the same value as I. Now let's typecast this particular integer pointer to double pointer and let's see what happens. So this integer pointer is typecasted to double pointer. Okay, and what will happen before that we'll go and have a look at our presentation. So integer pointer would have accessed 4 bytes starting from the base address and interpreted the data in 2's complement format because integer data is saved in 2's complement format. So integer pointer will comprehend the data in 2's complement format. Okay, now when the same data is interpreted by the double pointer, then first of all it will access 8 bytes instead of 4 bytes, and it will interpret the same data in double precision encoding format. So when we try to print the data over here, we'll see a completely different value. We cannot expect that it will, for example, this value is 10 and I'll get here 10.0.000. That will not happen. Let's see. See, we are getting 0 because in double precision format there is sine, mantissa, exponent, and and when in that format it is trying to interpret the data into its complement format, it is probably encountering that the value is 0 only. Another type of casting is when the pointer interprets the data in its own format and then the value which is obtained, that is typecasted to double. In that case, the over here, in that case, we are not interpreting the memory from the memory, but we are interpreting the value, and in that case we'll get 10.000 over here. Okay, so probably this message is not correct, but I hope the lesson was clear. These two type of typecastings might look synonymous but are very different, and I just wanted to pass on that difference to you. Okay, let's move on. Okay, this double precision format is for double, which means 64-bit data. Single precision format is for float, which is 32-bit data. I have explained in very detail and in-depth manner in part 7 of this series what is single precision format and how that calculation happens. Similar calculation would be for the double precision format. And if you are interested, I would suggest you to go and have a look at part 7 of the C programming series. Let's move ahead and look at another aspect of the pointer, which is updating multiple variables of the caller function. So let's suppose that this is the main function, and the main function calls this function and wants that two of its variables be updated by this particular function. Now, in C language, the function can only return one value. So what if this function wants that multiple values should be updated by this function? Here again, pointer comes to our rescue. Let's understand this with the help of an example. So I have this main function over here and two variables x and y. I want that these values be swapped using the function swap. So how would that happen? I will pass on the addresses of these variables and collect them in this function as pointers, and then I will exchange the value using pointers. So pointer will update the value at the address, and hence these variables would get updated without having the need to return anything from the called function. So let's see what does this particular function prints. So as you can see, the values before and after swapping are changed. So that is another use case of the pointer. Let's move ahead. Now let's look at arrays and pointers. What is array? Array is a pointer to a block of contiguous memory. So this is the block of contiguous memory, and pointer array is the pointer to the contiguous block of memory. So array holds the address of the first element of the array. Okay, and when array is indexed with a particular number, let's say 0, 1, 2, 3, then we can call this thing as dereferencing the pointer, in a way that when we put a array of 0, we'll get the data over here. Array of 1 will get data over here. When we index it, we can call it dereferencing, and without indexing, this is the pointer, or without referencing, it will hold the address. Okay, now let's look at it with the help of an example. So we have an array over here which is of length 10, and I fill in some value into it, and when I will print the first element, which is okay. Now let's have a pointer. Okay, and when I do PA equals to ARR, which means that I am putting in the address of the first element of the array into the pointer, and then when I dereference this pointer, I will get the same value as ARR of 0. So slash ARR. So as you can see, I'm getting the same value. Okay. Now, as I said that ARR is the address of the first element of the array. So ARR of 0 and ampersand of it is also the address of the first element of the array. So is this statement at line number 17 equivalent to line number 14? Yes, it is. So let's verify it. Yes, as you can see, this is equivalent. Finally, we look into what is segmentation failure. Segmentation failure occurs when the memory is accessed by the program in an invalid way. Segmentation failure is one of the most frequently encountered failures faced by the programmers. There are four reasons mainly for it. One is accessing variables out of scope. Let's understand it with the help of an example. So I have a main function over here, and this particular function has a pointer, and uh, it gets its address by the return of the function called calculate sum. Calculate sum returns this local variable over here. Now, as we know that the local variables scope is limited to this block, and if I try to access the local variables address the from this particular function, then it will give a segmentation failure. Let's try it out. Warning and all is okay for now, but as you can see, it got hung over here, and this particular event indicates that there was a segmentation failure. So to summarize, accessing address which is out of scope would result in the segmentation failure. Another reason for segmentation failure is the use of uninitialized or dereferencing uninitialized pointer. So this makes this particular pointer as uninitialized, and when I print it, which means when I try to dereference the uninitialized pointer, let's see what happens. It will again go for a hang. Okay, so this again is the condition of segmentation failure. Another condition of segmentation failure is trying to access the null pointer. Okay, let's see what happens. Again, it got into a waiting mode. So this was the indication of the segmentation failure. Segmentation failure can also occur if we try to write in the array beyond the size of the array. So let's suppose I try to write on 100 indices for the array of size 10. Let's see what happens. So this again went into segmentation failure, right? So these are the four conditions. I'll repeat for you. Accessing variables out of scope, dereferencing a null pointer or an uninitialized pointer, or writing beyond the size of the array. These would result in segmentation failures. These are invalid ways to access the memory. So I hope this was clear to you. In the next video of this series, we look into string utility functions which can ease our work while dealing with strings. And then we come to one of the most interesting topics, which is searching and sorting algorithms. Thank you and see you all tomorrow. Bye bye.